Hello, everyone. I'm really sorry about getting this out to everyone late. I started recording last night, and apparently my screen recording software did not take it, and it was a little late, so I just didn't want to redo it. But I'll go ahead and kick this off. So this is going to be your introduction lecture to the course introduction for software-defined networking at Florida State College of Jacksonville. This is CNT 3105, and I'm going to be your professor for this course. My name is Sheldon Swanson. All right, so a quick little overview of just this presentation and what we're going to be covering. So I'm going to cover myself, my background, and how it relates to software-defined networking in this course. We're going to do a quick little high-level overview of the course and the different topics that we're going to be covering and studying. I'll give you an expectations and breakdown, everything that is included in the course, what's expected of you, and how you can gain points to work towards your final grade. I'm going to be covering software-defined networking theory. The theory itself is rather simple, so I'll get to that when I get to it, but you'll notice that kind of like that's why I've chosen to make this class focus on the tools. I'm going to be covering application programmable interface, otherwise known as APIs, because software-defined networking and just the new way that we're starting to deploy these applications and items at an infrastructure level relies very heavily on APIs. This is a heavy scripting and coding course, and for a network engineer, the best language of choice has kind of been Python. It's what Cisco decided to go with, and it just has a lot of built-in modules for network engineers to make use of, so it just made the most sense. I'm going to be covering some of the net Devops tools that we're going to be using in this course and that you would use in the real world in the job. Linux. DevOps in general is very Linux heavy, as is software defined networking. So I'm going to be covering Linux, and your first lab actually is a refresher of Linux focused material. We're going to go over software development lifecycle. This is where we're actually going to start to get into the book. So the book required for this course is the Cisco Certified Devnet Associate Certification Guide. It's brand new. It just came out. And previous revisions of this course, I was trying to prepare for this book to actually come out, because that is really what it covers. One of the great things about FSCJ is the labs and kind of the material that you cover is it relates directly how it's done on the job, and that's why I wanted to keep this course focused on the tools, and actually that's what the DevNet Associate program and certification do for you. We're going to be covering software development and the different models that are used to develop software amongst groups of people and within organizations. Git, which is a command line tool used for version control of software, because when you make changes to software, you need to be able to differentiate what was changed from one revision to the next, so that you don't make any mistakes and you can always revert back to a previous revision. We're going to be covering code reviews, which are very similar to change management reviews, and I'll be covering those when I get there. Because I'm already late with this, I'm not really going to have time to go into a demo, but there's really not too much in this lecture for me to demo on, and I will cover that as we actually start to get into the material, and then finally we'll move into our summary. So about me, for those of you who haven't had me before, I'm originally from Lincoln, Nebraska. I joined the Navy right out of high school when I was 18. I left for boot camp when I was 19 in Great Lakes, Illinois, and I joined as what is called a fire control systems technician, otherwise known as FC if you've been in the Navy before. I was one of the Aegis types. I went through about 2 years of technical training on electronics and electronic theory, mostly related to hardware and signals, that were really focused on the systems that I was going to be working on. After the 2 years of going through A school and C school, I lived in Chicago for about a year, and then Dahlgren, Virginia for about another year. I got orders to come down here to Jacksonville, where I got stationed on the USS Gettysburg out of Mayport, Florida. I was there stationed on there for 5 years. I worked my way up to work center supervisor, so I've traveled the world a little bit, got some pretty cool port visits under my belt, nice work experience. And when my time was up, I was in FC2, that's an E5 for you non-Navy folk, and I was up for shore duty, so I decided to explore my options, where I got to go to shore duty and become a visit board search and seizure team member instructor, and I was also the course supervisor for that course. So I have written a course for the United States Navy that it is still used today. I was also the VBSS boat officer course supervisor, and I assisted with Security Reaction Force Basic and Advanced. I was the Master Training Specialist Coordinator, which Master Training Specialist is your certification for just overall, becoming a good instructor. So a pretty decent amount there. The material that I covered, though, it was mostly related to police-style work, hand-to-hand combat, searching detainees, containerized inspections, and got to spend about 3 or 4 years shooting guns, so that was pretty fun. But while I was there, I also enrolled at FSCJ in the AA program. And when my time came up to either make a decision, I had about a year left in this program, and I really enjoyed the material. So and they wrote me orders for a boat in Norfolk, Virginia. I really wanted to test out, see how I could do in the civilian world. So I decided to roll the dice and finish off my degree at FSCJ. Following the Navy, I got my initial help desk experience out of Jacksport, where I worked part-time while still continuing in this program. I had my A+ at that time, and finished my Network Plus while I was there. Did about 3 or 4 months in the help desk and was still searching for a more steady work and in something I was more interested in, so I was looking for network positions, and I got a job as a contractor network administrator for Swisher International, which is in downtown Jacksonville. Finished my Security Plus while I was there, my CCNT, and then I finally graduated with my bachelor's. My contract came to an end, so I was on the job hunt again, and I ended up getting picked up by Public Supermarkets. So I moved down to Lakeland, Florida for about another year and a half, where I got my initial experience in a large enterprise as a network engineer. My team was focused in application load balancing, and they were really pushing me towards wireless while I was there, because there just wasn't a lot of wireless people. And my team also owned the Infoblox DDI, which is DNS, DHCP, and IPAM, which is it's an IP address management tool. Those are all very common that you're going to find at large organizations. Started working on my master's while I was there. I went to University of South Florida, attended my master's in cybersecurity, focused in digital forensics. Finished my master's, finished up my CCNA, and I really missed Jacksonville a lot at that point. Lakeland, Florida just wasn't very fun, so I started looking for work back in Jacksonville, and that's when I got picked up by Web.com Group, and I've been with them ever since. We are now called Newfold Digital because we've got a lot of brand names underneath us. I work for them as a network engineer. I've done a lot of net DevOps work for them. I've introduced automation, Ansible, scripting. Used to own the network monitoring system, but I've officially given that off to another team just because that was driving me insane. I've built a few custom network applications in Python, some things like backup devices, and really, your ability to learn a programming/scripting language, you can build whatever it is that you want. So a couple of custom stuff just really tailored towards our organization, and I've really started to use the material that I've learned in Cisco Devnet to leverage, our APIs and get system integration together, and that'll make more sense as we start to get in the material. I would say my latest focus with them over the last year or so has been starting to push more towards security, which is what I want. So I've been doing a lot of security work for them as well. Non-tech wise, in my spare time, I'm a drone pilot. I like to fly my drone, just develop content, get content creation going on. I like to exercise. I'm a pretty good chef. I've taken a few classes on cooking. So if anybody wants to talk anything non-technical, I can talk about cooking pretty well. Most of all, I love hanging out with my friends, and as you'll hear in the background from time to time, as I do these lectures, I do have a 5.5-month-old puppy who has just been my world and sucking out a lot of my time. And on the right, I've got my credentials. So education, I've been through Naval Education Training Command. I've been through instructor school. I do have my Master Training Specialist certification through Naval Education Training Command. I also went through Small Arms Marksmanship Instructor School, which they took a different approach that was more of a hands-on approach, so that was really nice. Through FSCJ, I've got my Associates in General Education, which is their university transfer degree. I've got my Bachelor's in Computer Networking Telecommunications. My Master's is from University of South Florida in their cybersecurity program, focused in digital forensics. So I have my MTS, which is Master Training Specialist, and still current are my A+, Network Plus, Security Plus, CCNA Routing and Switching, CCNP Enterprise Core, and this slide's a little out of date because in progress I have a Wireshark Certified Network Analysis, which that's going to be a much longer certification, but I've got CCNP Enterprise Advanced Routing on there. FSCJ actually put me in the Cisco Devnet instructor course, so I really want to knock out that certification probably sooner rather than later, just because the opportunity came knocking at my door. And I'm working on some Fortinet certifications as well. I really like their products, their platform, and I've done a full rollout and design at web.com. So I've been getting really into those and like to help FSCJ develop their Fortinet Academy material. All right, so course overview and some of the things that we're going to be covering. So yes, this class is labeled Software-Defined Networking. This is a network-focused course. But the theory behind software-defined networking, there's only so much that I can have you do without doing anything hands-on, and I'm just not a fan of a lot of the open source solutions out there. Open source solutions are an amazing way to kind of get some experience without having to pay for tools that come with support, or tools that you would use perhaps like that your company provided you. I'm working on getting a much beefier lab, but I have been able to gather the resources necessary that we can actually get our hands on a software-defined networking solution. But realistically, what it's about is I want to give you hands-on experience. So experience working with a software-defined network solution. To me, that's much more important than the theory, because the whole point of software-defined networking is that we simplify networking and we need less people to manage it. So a lot of this is accomplished through these things called APIs, and we'll be covering APIs a little bit more in its own dedicated slide, so I'll get to there when I get there, as well as scripting and coding. I've got another slide dedicated to that, so we'll kind of get into that a little bit. The first thing I do want to say real quick, because we've got scripting and coding with Python right there, you've got the Python symbol. I really want to let everyone know to relax and trust me a little bit. Wait till I get to the slide on scripting and coding with Python, because I do take a different approach than your standard programming course if you've ever taken one or had a background in that. Be covering some of the different net DevOps tools that we're going to be using in this course and that you would actually use on the job, because that's really what it's all about. This course is all about, is just kind of getting you hands-on experience with those tools. I'm going to be covering Docker containers later on, because that really relates to just where everything is going, and containers are very lightweight. You may not really understand what they are. If you can think of a virtual machine, a virtual machine is still pretty heavyweight because it contains like the entire computer, the whole operating system, all the processes for that operating system to work. Well, containers are a much more extreme stripped down version of those, and you do have a lab on Docker where you'll be building some containers, and hopefully that'll give you a better idea of what they are and how they could be useful. I left Kubernetes orchestration in this slide just because I want your head to start thinking about it, because you're going to hear about it a lot, and it was the longest time before I actually understood what Kubernetes did. In the previous revisions, I did have a Kubernetes lab, but I had to eliminate that to make room for the Linux refresher. But I did want to just kind of put it in there, and all that does is it orchestrates containers, and containers are the latest and greatest way that we are deploying applications, because they're much more lightweight than the traditional way we've been using to do it, and that makes them very friendly for the cloud pretty much any cloud platform. And then we're going to be covering Ansible automation, and I do have a lab at the very end where we're going to be actually automating some network configuration changes on a more traditional network device using Ansible and developing some playbooks. All right, so expectations and breakdown. So this is a modular-based course. Each module, I do want to point out that this is a 16-week course, but it is compressed into 8 weeks. That does not mean that you only get half the material and get full credit for the course. That means I had to take 16 weeks of material and cram it into 8 weeks. So it's very important that you stay on top of it and that you understand that, yes, this course is going to require more than your average time because it's 8 weeks. I've been getting lots of complaints about that, but when I ran this course at 16 weeks, I didn't get those complaints. So I would just encourage you to remember that this is a 16-week course, and just because it's a 16-week course, that does not mean in any way, shape, or form that I would take away from any of the material, because really I'd just be hurting you, the student, who needs the experience on this and needs to learn, kind of the base theory before you can move forward. Each module is going to have one lecture and one discussion board. 2 labs per module and 2 quizzes, and that's basically there just so that I can still break this up into a 16-week course when I actually offer it at 16 weeks, because if I still offer it as like basically a 7-module course at the full 16 weeks, what I have found is that people don't do the work until the last minute still, and then they've just crammed the 2 weeks worth of material into about a couple of days, and it just doesn't work out very well. The quality is not the best, and I feel like retention on theory is a lot lower. So here are your grades. Your introduction discussion, you're going to have one of those, and that's worth 40 points. The introduction discussion also counts as my roster that you plan on attending this course, and that is due by Sunday. So if you do not complete that introduction discussion, you will be dropped. How do you know that you are dropped? You are going to log into Canvas someday, and the course is going to be gone. I'm getting much more strict with this because I started to take kind of on some of the blame with people not completing that introduction discussion, and I started then sending out reminders, and what I found is it didn't help. I had a lot of students that even said, yeah, no, I saw your reminder come through, I just didn't think that pertained to me. So I'm not going to waste my time with reminders anymore. It's due on Sunday. If you don't have it done by Sunday, you're going to be dropped from the course, and I'm getting more strict about it. I'm probably not going to let you back in the course because I'm emphasizing right now, complete the introduction discussion almost immediately after you watch this video. It only takes a few moments to get in there, say your name, a little bit about yourself, and let me know that you plan on attending the course. If you watch this video and then you decide, oh, I'll get that done tomorrow, and you procrastinate, put it off, or forget about it, you've missed the introduction discussion, you're going to get dropped from the course. Labs, we've got 14 at 35 points total. I've actually removed a project from previous revisions of this course, and I've moved those points to the labs themselves. So your labs total up at 490 points total. Quizzes, you're going to have 14 of those at 25 points each. Your quizzes are going to be, the questions from your quizzes are going to be pulled from the book, any required reading that I give you, the lecture, and the labs. So the way I've set up this course is I have opened it completely up, although you might be waiting on me, depending on how fast you move, to get some of the material back out, because I'm just making my final updates right now. But how it works is, you watch the introduction lecture, you do your introduction reading, and then everything is in sequential order. And if you complete all the items in the module, that means you have to have everything turned in. You've got to complete the quiz. You get 1 attempt at the quiz. It's a timed quiz, and I try and treat them as a nice bridge gap between certification exams and college exams. So these are upper level courses. You're in your bachelor's at this point. It's a 300 level course. So do expect it to be a little bit more difficult. And your discussions, you're going to have 6 of those at 20 points each, and that equals 120 points. So a total of 1,000 points, and it's a standard, 900 to 1,000 is an A, 800 to 900 is a B, 700 to 800 is a C. Anything less than that, you will have to retake the course, and just using the standard grading structure for this course. I do want to add, sorry, I'm looking over some notes right here, is for your labs. I have renewed your VMware Workstation Pro licenses just for being in this course, but unfortunately, I've had too many students in the past that are completing these labs use things like VirtualBox, which I'm telling you right now, you're probably going to run into issues. It's free, and it's free for a reason. And I built the VM using VMware Workstation. So you've got the software available to you there, but then I also ran into a double problem where people were actually doing their labs at work, and you don't know what content filtering that you're doing or that your security is doing. And a lot of these labs require you to access specific websites and pull down packages that for your everyday user could just potentially seem out of the ordinary and potentially malicious. So I now have to ask that you do use the Horizons machines, which I'm going to post an announcement with a link to the FSCJ Horizons machines. I've allocated extra resources for you. Workstation Pro is already installed there, and the link for the SDN VM is available for download. I will post an announcement with the credentials to log in. And I'll get more into the SDN VM in a second, but also in the labs. I give you the actual lab, and then I give you an answer sheet. You are required to give to me the answer sheet, which is mostly screenshots. I've been getting a lot of complaints about screenshots, so what I would suggest that you do is set up screenshots efficiently. It's something that you're going to have to do in the real job. I have to do them all the time. On a daily, I probably take, at least, a dozen screenshots, if not more. The tool that I like to use, I'm not really selling you on a tool or anything, but it is freeware. It's called GreenShot, so you can go to their website, you can download it, and I just really recommend that you set up your print screen key or some kind of hotkey to capture a region, just because it makes taking your screenshots more efficient. And some tips for success: don't spot read the labs, don't spot read pretty much anything that I give you. Spot reading is, kind of like you're just grazing it over, you're trying to get through it quick. If you spot read, that's a very bad habit to get into, especially when you're reading technical manuals, how-to guides, or anything resource-wise, learning how to do something, because chances are you're going to look over like a very key configuration item. And I say practice and keep practicing. Just because you attend a course, that does not give you the skill. It gives you the base knowledge for the skill, but just like if you were playing basketball, a sport, or trying to learn any skill, you have to learn it in order to hone those skills. And how do you do that? By practicing. So get creative, have confidence, and remain persistent with your practicing. The more you practice, the more you're going to see your toolbox build up, and the more fluent you're going to become with these skills. All right, so software-defined networking, what is it? Well, to really get into software-defined networking, I have to cover a traditional network. So a prereq to this course is you should have taken Cisco at this point and accessed some Cisco gear via the CLI. That is the traditional way in which networks are managed, device by device through the command line. It's very inefficient. It makes troubleshooting much more difficult. In a traditional network, I usually have to log into several pieces of network equipment to get the full picture of what's going on in order to help troubleshoot something. So what they've done is they've started to kind of turn it into a more automated solution in which we separate the control versus the data plane. So what's the control plane? Well, in your traditional network, that would be the CLI. As you are accessing it, you are applying configuration to it via the CLI. So you are controlling the configuration on that device. The data plane is going to be how the data and traffic actually flows through that device. So they're two separate things. In a traditional network, they all live on the same box. What they are doing is removing the control plane and just putting it into a rack-mounted server with a web application on it, so that you can just access a web application through like Google Chrome or Safari, Firefox, whatever it is that you choose to use. And then you can configure and manage your network through a nice little graphical user interface. The components that make it up are going to be the web application, and that's how you interact with your network from that point going forward. A controller, and it's just not a very big deal to understand the inner workings of the controller. If you wanted to do that, I would suggest you go get a computer science degree, because that takes some pretty advanced knowledge in firmware. So all that you need to understand is that the application takes the input that you, the network administrator, give it, and then it translates it to something that the network device can use, and it pushes the configuration down to the network device. So that provides us a central management, which is a nice single pane of glass to manage our entire network, going device to device, accessing it through the CLI. So what's up with these APIs, and why are they so important? First, there's only so much that you can do with a GUI before you just make the graphical user interface way too complicated and nobody likes it. So you've got to simplify the graphical user interface, but there's a lot of options that come with configuring network devices. So that's where these APIs things come in, and that's how you are going to actually interact with the application, the SDN application, and it allows you to do things like script against it, so you can do if-then-else statements, and you can do conditional matching, you can count, and it just opens up that realm of possibilities. But they also allow for multi-vendor integration. What does that mean? So let's say I have a ticketing system that I purchase. I'll use, for example, ServiceNow, just because it's a very common and popular ticketing system right now. What we can do is we can take the API, which is just a logical piece of software, a way to interact with that software. So I can open the API on ServiceNow and on the SDN application and have them communicate with each other. So if a device goes down, or almost any process that you need automated, you can just connect the APIs together. And then we've just automated a lot of the old manual workflow in which we would have needed a human to solve that. You've got these things called Northbound and Southbound APIs, which are outlined in your book. And all that really is kind of like, if you're looking at it on a picture, how the API is communicating. So what you're going to be accessing is going to be a northbound API, but like what the controller is communicating to the network device, that would be like a southbound API. And I'll probably cover a little bit more on north and southbound in a separate lecture. But with APIs, we'd open up these things. Actually, you know what? I'll save that for the next one. But we do have different formats in which APIs are exchanged. And you know what? That's just better for the next slide. All right, so APIs. Application Programmable Interfaces. It is just a logical interface, a piece of software, something that allows me to interact with that application. So what they've done is said, let's not reinvent the wheel. We're already accessing the application using HTTP, HTTPS. I just seem to have left the S out in this diagram. So we're using those protocols to interact with the API. We've got tons of labs on APIs, so you're going to get very familiar with them. But really what it's about is pulling down information about the network in a structured way. So the most common one that we're going to have is JSON, which, as you will find, it's just key value pairs. So I could have like interface, interface description. That could be the key. And then the value could actually be the description for that interface. We can make use of the status codes that are already built into HTTP, HTTPS if something doesn't exist, if you don't have authorization to do it. And then really when creating API calls, you've got to be familiar with the headers. And what headers allow you to do is it's just information about the conversation. So the most common thing I could use as an example of something that's put in an HTTP header is website cookies. Those are put in HTTP headers. So those cookies are transferred with the HTTP requests, and that just provides you with a better experience. So what we can do is we can send in things like authentication API tokens, how we want to read that data, how we want it received from the application. And like I said, the most common one is JSON or JSON. I personally say JSON. I don't know why, but you can pronounce it either way and people will know what you're talking about. And that's just a structured way that we are going to receive and provide data to the application. They allow us to exchange information, retrieve, and actually provide information to the network so we can make configuration changes through APIs. And then we've got these awesome things called webhooks. Those are most commonly used in collaboration platforms like Microsoft Teams or Cisco WebEx Teams, where you basically just have a collaboration platform and everyone just uses it to communicate with each other. But you can do things like set up chat bots, and they can inform you if something's happened, or they could automatically post a message to a specific channel in a collaboration platform if something happens. So based on a condition, something happens. And you'll notice that's where I'm hitting on again. It's all realistically about automation and automating a lot of the tasks that we used to have to do manually. All right, scripting and coding. All right, so for a network engineer, I would say even the Cisco Devnet book chose to go this route, is with Python. Python is very easy to read. I feel it's probably one of the more easier languages to work with. The industry typically has kind of been reinforcing that because it's so easy to learn. It's open source, so it's compatible on Windows, it's compatible on Mac and Linux, you name it. It's very powerful, but this isn't the only language that we have available to us. You could also use Microsoft PowerShell if you're already familiar with it, or perhaps you're a Windows system administrator. But learning how to script with a programming or a scripting language, I'm not trying to make you an application developer. What I'm trying to do here is teach you the core fundamentals so that you can use this tool, this scripting and programming language, in order to help you out on the job and automate repetitive tasks. You'll notice in the recommended books for this, I didn't add it as a requirement, but I added Automate the Boring Stuff with Python. I chose that book very specifically. I've got quite a few Python books, and that one alone, if you read it, can really help to automate a lot of tasks for anybody who has an office job. So just flip through it a little bit, and you'll notice that you can automate things like it. What I try to encourage people to do is, if you find yourself doing repetitive work that just takes no brain power to do, I've got to move things from this column to that column, I encourage you to say, can I automate this? Can I use Python to automate this? Chances are you're going to be able to, and that Automate the Boring Stuff with Python will really help you out with it. So that allows you to kind of help learn Python, and maybe not so much in a network or academic environment or point of view, but just to help you out on the job and make your life easier. I recommend right now that you pick a theme that interests you for this course, because you're going to need it as you walk through labs. I cannot practice for you, but what I can make sure you do is practice, and it's what I've noticed a lot of people are doing. They just do the one task in the lab and then they move on to the next task. Well, you've got to do that task a few times in order to develop any type of repetitive action or commit it to memory. So choose something. It could be a hobby, a favorite TV show, a sports team, or a sport that you like. You could use your family members. Just something that you have a detailed knowledge of and would be able to provide those details, and you'll kind of notice when we start working with the programming languages and Python how that would apply and how you could use it. I personally believe that people hate learning programming languages, because I did take a Java course before entering into FSCJ's infrastructure program, and what I feel like, and I could be wrong about this, but to me, it was that math was very heavy. It's not that I'm bad at math, and it's not anything against anybody for being bad at math, but math is probably one of the best ways to actually teach people how to become a developer especially when it comes to applications, because they can be very math heavy. And just from my viewpoint, what I'm asking you to do in an introductory course is to do math in another language that you just learned. So to me, that alone is very discouraging, and it's also very frustrating. I've tried to stay away from that as much as possible. The most math that I have you do would be, like, is this number greater than or less than this number? But there's just not a lot of math involved in scripting and infrastructure-wise, especially when it goes to APIs. What you may have to do is just some counting, some basic counting, like, okay, add 1 to this variable and keep going for every iteration of this loop that you go through, but that'll make more sense when you get there. So I'm not doing any multiplication, division, or anything like that, finding the square root, the ratio. I try to eliminate math as much as possible because it's just not heavy when it comes to scripting and automating infrastructure-related tasks. And neither is the book that I recommended. So I try to keep as little math as possible. You'll only have to do some basic counting. Virtual environments. We're going to be working with these things called virtual environments. That's separate from, like hypervisor virtualization, where you're virtualizing computers. What it more is it's just creating a fresh bare bone instance of Python, because we have to install these things called packages, and we're going to be using, it's right there, it's pip. We're going to be using pip to install these packages, and that stands for Python installs packages. And when you install these packages, what they are is it's just pre-built code that people have developed and published to make specific tasks easier. So for instance, the Python package that we're going to be using to interact with APIs is going to be the requests Python package. So as we install different packages for whatever it is the project needs, we can populate it into what's called a requirements file. And all that is the output of a pip command where it lists all the requirements from that virtual environment. You output it to a requirements.txt file, and that way if someone wants to recreate or work on your project with you, then they already know the necessary Python packages that are required in order to get this project working. Variables are very heavy in scripting and programming, and if you're not familiar with it, all it is something. It's a piece of code. It's something in memory that you assign a value to, and that value could be one of many things that'll be covered a lot in your labs, but loops are really what help coding and scripting work, and that is like, if interface equals down, then enter command interface, administratively down the interface. Or if, like if you see something that's a certain way, if computer equals on, then turn off, so we can actually develop some logic into our programs and make it do stuff that we want it to do. And it really, as you'll work through some of these labs, you can see automate some of the repetitive tasks. And that's what I mean by if you're doing something that requires no brain power, but it's just a repetitive action, that is a very good candidate to look at, could I automate this? Because chances are you're going to be able to just utilizing some of your basic Python theory. All right, so net Devops tools. There's a lot out there, but I just kind of stuck with the basics on what we're going to be covering. So we're going to be going over GitHub, which is a online code repository, and that's just a place for people to store their projects so other people can work on them. And they can use Git, which is a Linux command line application for working with code, looking at differences, committing changes to the core code base, which would live in GitHub. If you don't have a GitHub account, I do encourage you at this point, go ahead, just log into GitHub, create your account, because you're going to need one to work through some of your labs. Other common tools are collaboration tools. So I covered like Microsoft Teams. The Cisco version is Cisco WebEx Teams. There's also freeware out there such as Slack and Flock. And it's just a way for you to chat and communicate with people, share GIFs. They're kind of fun. But as it relates to kind of like the DevOps environment, is allowing us to exploit those things called webhooks that we were talking about and automate messages to specific channels based on what we see. Linux is definitely the the operating system that really DevOps only works with, because some of the tools are only built for Linux. We've got the ability to do bash scripting and use bash to look through things like files and automate the creation of files. Curl, which is another Linux command line application, which allows us to test APIs from the command line. It's not used to script against APIs, but it can be used to test them, as well as there's a graphical option that we're going to be covering in this course as well, called Postman, and that is also used to test APIs. It's a great way to start when you're trying to automate something that has an open API, or see the information that's returned by doing an API call. So those are the different tools that we can use to actually test our APIs. And then we've got the Git command line application, and what that does is allows us to make changes to code, commit those changes. It keeps a rolling update to any changes, and then it has this concept of branching. And I actually get into Git a little bit further, because Lab 2, that's what Lab 2 focuses on, is going to be learning the Git command line application. All right, on to Linux. I was getting lots of complaints about Linux. So it's comical, because some of the complaints I got were, I've never touched Linux, and that's just not true. The Linux course is a prereq to this course. It's called Introduction to Operating Systems. It's like the first course that you take in this program. So you've already taken the course. You should have already have a Linux Plus book, or you can access Safari and look at any Linux Plus book on there, but you've already taken the course. So I've already sacrificed enough, such as the Kubernetes lab, in order to provide you with a Linux refresher, but on the job, you're not going to have somebody there that you can say, oh, you know what, I need a refresher in this, could you sign me up for this course? That's just not how it works. What you've got to learn how to do is use the resources that you have available to you, the ones that are built into Linux, online. You may find that you like one website better than the other, one book better than the other, but you've really got to learn to start to be self-sufficient with picking up some of these tools. So I'm not going to be covering Linux or any of the theory, because you've already had the course. And it's a prereq to this course. I don't have time to go back and completely reteach it again. If we wanted to sit here and keep covering the same material over and over, I could suggest that you take a certification course, but you would end up paying for it every time that you go over that material. And this is a high-level course. This is college. The only other institutions that I can think that you learn material repetitively are elementary and middle school. So you've had the course. It is up to you at this point to practice. I can't practice for you. Nobody can practice for you. So if you're not practicing, that's where I just encourage you to continue to practice. And that really just hones your skills. That's how you become familiar. That's how you become more advanced. And not to mention, a lot of these skills, they're perishable. So what does that mean? It means you use it or you lose it. If you're not practicing, you're going to start to forget commands, different options, and way to use those commands. In the lab, I do offer a pretty decent sized cheat sheet on some of the common commands. But that's really what you need to do. And I put in there the SDN VM, so I've got a pre-built VM with all the tools required to complete your labs. There's actually also still a Kubernetes Minikube instance installed on the SDN VM, so if this material interests you and you want to continue on, I will let you know that the SDN VM that I created for this course does have Minikube installed. So if you find a Minikube tutorial on the web, you can use the SDN VM to complete that tutorial. But realistically, the SDN VM, I've given you root access for. There's one user on there, one password. I'm just getting so many calls about people having some basic Linux problems that you really need to start to learn how to troubleshoot and work through on your own. So I'll tell you one thing, you've got full root access to that. I got so many text messages and calls about the SDN VM not working. Some people were turning in labs saying, oh, I got to step 2 and then I got a permissions denied error and I couldn't finish the rest of the lab, but they never reached out to me. If you do that, you're going to get what the your work has earned. This is an upper level course, and that's just not an excuse for not completing the lab. Everyone on here you've got my personal cell phone number. Best way to reach me, as per one of my announcements, is a text message. I may not get to you right away, but I have seen your text message. If you feel I forgot about you, by all means, shoot me a little reminder. If it's an emergency, by all means, just annotate that in the text message. I'm just a busy person, but I do make time. Do not cold call me. If you cold call me, I will not answer. I get enough cold calls a day. Best way to reach me is a text message. Alternatively, you can email me at my FSJ email. Just don't send it to my student account because I still have one. Make sure it doesn't say @students.fscj. You can also use Canvas as a last resort as well. But sorry, I forgot to add that in the beginning. So back to Linux, some things that you must know in order to really be decently fluent, because Linux is going to be something that you come across again, guaranteed. Is your basic navigation. You need to know how to move around the command line. You need to know file and directory management, how to create them, how to manipulate them, move them, interact with them at the command line level, how to get help. There's a lot of stuff built into Linux that will help you either figure out what a command does, the different options, and it explains that for you. There's abbreviated versions, and then there's manual pages. They're all there. Linux permissions, again, I can't stress this enough. You have root access to that VM. You've got all the permissions you need to do anything that you need. So if you are getting a permissions error, it is up to you to learn how to fix that. And the biggest thing I can encourage you to do is read what the command line is telling you. Chances are it is going to at least point you in the right direction. And have some confidence. Go take a look, see what can happen. If you need to, make a snapshot of the SDN VM, create a clone of the SDN VM, and then work on that one. That way, worst case scenario, if you break it, you just delete the clone, but you still have the original. And you should be looking at some of the things like system variables. You should probably become at least a little familiar with what those are. And I put this in here as well as some of my notes. Linux applications are not Linux. I got lots of, Professor Swanson expects us to become experts in Linux. And it's like, no. Git is not Linux. That is a Linux application. There's a big difference. Command line tools are not necessarily Linux. They are applications built for Linux. There's a big difference. So when you go through your Linux refresher lab, those are Linux commands. Those are bash commands. The difference is a Linux application. I mean, that the best analogy I can use, that'd be like calling Microsoft Word Windows, or iTunes. That'd be like you calling it iOS or something like that. And I just want to make sure that we're clear on that. But you do need to start learning to troubleshoot your own issues and build your skills. You can still reach out to me, and like I said, best way is a quick text message. That way I can ask you for a screenshot or to take a picture. I can just take a look at the picture, and most of the time we can resolve it within just a few minutes. I had to make room for this. I just want to point that out because it was a big complaint I've gotten, and it was just very, it's very disappointing because you've had this class already, and I now had to sacrifice hands-on experience with the de facto container orchestration solution out there to make a refresher for a class that you've already had. So I would just like to point that out because that's what I was getting enough that I'm like, okay, well, I've got to sacrifice something, and I'm going to have to end up having to take Kubernetes out of it. So now you're going to be leaving this class with one less tool that you've had hands-on experiences so that you can have a refresher in some material that you've already taken. It was just disappointing to me. All right, so software development lifecycle. I'm actually in the Cisco Certified Devnet Instructor course, and I've noticed a few conflicts on this. So You may look this up and kind of see them a little out of order, but this is how it's outlined in the Devnet book, so that's why I have it up there. And basically, all this is, like you can just go out and start building software, but you're probably not going to be very successful at it. The better way to do it is in a structured manner and using some kind of model in order to complete it. So the planning stage, this is going to be what is the problem that your application, your software, your script is going to solve, and what are the requirements that you have for that software, for that application? Does it need to be containerized? Does it need to run on Windows? How will it be tested? There's different forms of unit tests, especially built into Python. And how and when are you going to deliver it? And this is also where you develop your software requirement specifications. And all this stuff is also outlined in your book. Stage 2 is when we're getting to defining, so what is the software supposed to do? Then we move on to stage 3, which is turn the software specification into actual software design. You do need to design the logic and the theory when you're building out applications, scripts, and really any type of software. Stage 4, building, and this is where we actually start coding. Funny thing about that is this is actually supposed to be the most easy part and the part that takes the less time, because if you do everything properly leading up to the building phase, actually sitting down and writing the code should be a breeze, because at that point you're just translating the high level design and the logic into functioning code that's actually going to work. And then you need to test it. Does it work as expected? Did you find any bugs? This is why you get so many software updates on a lot of your stuff. They find bugs, they find security vulnerabilities, whatever the case is. It means someone's reported it, they've looked at it, and they've said, oh, yep, we didn't test for that. And bugs are becoming more and more minor as far as the functionality is concerned. But that is the whole point of testing. And then deployment. This is where you put it into production. If you've ever heard of a beta is like the first stage of deployment, and that is where you give it to actual end users to put it in their hands, but you're not saying that this is a full, stable working version of my application, my code, my script. This is a trial version where I need you to actually give me some feedback and identify areas of failure or code bugs. And then debatable on there is maintenance, because it's not outlined in your book, but it's definitely outlined in the Devnet associate course that I'm in. And that's going to be, continuous integration, continuous development on the application. If you don't do that, then you're not going to fix software patches. You're not going to add features that your end users are wanting. And ultimately, the software will eventually die. All right, so software development, there's a lot of different models out there, but I focused on some of the 3 most common or popular. That includes waterfall, lean, and agile, all of which are outlined in your book, and there's plenty of resources online for you to go take a look at them. At a high level, really, what waterfall does is it mirrors the software development lifecycle. It goes in one direction, and you cannot start on the next step until the previous step is finished. So although this is popular because it's a very structured way of doing it, and mirrors the software development lifecycle, it's also a very simplified way of developing software, so it's not very advanced. Then because we've identified, different areas of improvements in some of these, that's why we've came up with more. So there we've got also the lean, which lean focuses on the elimination of waste. And they also focused on producing the code just in time and continuous improvement, so that makes it a lot more efficient. And then we have agile, and from what I understand, for the most part, I think agile is probably one of the most popular one. It's very flexible, and it's focused on the customer. It's got this thing called the Agile Manifesto, and that manifesto has some basic principles defined in it. Those principles are customer-focused, embracing change and adaptation, frequent delivery of working software, collaboration, motivated teams, face-to-face conversation with team members, having working software, working at a sustainable pace, agile environment. They like to keep it simple, so simplicity is best. Self-organizing teams and continuous improvement on the application. And then we've got different design patterns right here. And that's basically what they're going into is they're not trying to reinvent the wheel. So we've got the model view control pattern and then the observer pattern. So model view control model is kind of like the retrieving and manipulating of data, where the view is what the end user actually sees, and the controller is going to be an intermediary between what the user sees and then that back end logic. And then you've got the observer pattern where you've just got a simple subject and observer. All right, Git. So Git is a Linux application. It is not Linux, it is a Linux application. It was actually developed by the same person who invented Linux, Linus, I can never pronounce his last name. It's Linus Trinenbald or something like that, but he's the one who created Linux. He also created Git. And what it is, it's a version control system. And what that means is when you make changes to the code or changes to the software, it's tracking every last one of those changes. And it allows you to work on these as a group, and it's a very distributed architecture. So for example, GitHub is the repository where the core code lives, but many developers can then make a copy of it using the clone command to their local workstation, and then they can make branches, which are going to be another working copy. And I think branches actually just become more familiar when you start to create them, because each branch has a parent branch, and if you were to draw it out, it actually does start to look like a tree branch. But it allows you to make a full working copy without disrupting the original code. It's open source, so it comes in Linux by default. You can also get versions for Windows. I've got a Mac, and it's on my Mac, and it's built into a lot of different code editors as well. One of the things that makes coding easy is working with code editors. So some popular free ones out there are Notepad++, but that's very basic. Personally, I like Atom for the freeware version of a nice code editor that interacts with Git and GitHub. The paid version would be, I would say, like the closest thing would be Sublime Text, but you've still got like Microsoft Visual VS Code, or Visual Studio, whatever it is. There's tons of products out there. It all depends on what it is that you like to work with. But I do recommend that you use a code editor in this course, vice just using a text editor, because a code editor can help you spot out errors, and sometimes things like Atom, they can actually finish the code for you as you start to type it, and it just makes building it a lot less painful. All right, so we've got that tree structure, which creates that logical workspace. You clone it down, and it creates a full working copy, and then you can create different branches to make more copies, and you then want to stage those changes into what's called the staging area using the add or remove command. And all that's saying is, okay, I've completed this little piece of code. I'm going to add that to the staging area, and then when I'm completely finished working, I will commit all of my changes that are in the staging area to the master branch. So you've got a header local repository. So remote would be something like GitHub, and local would be that could be internal or external. External, you could think of GitHub, but there are internal ones that you can get, both freeware and paid for solutions for, companies that develop software as part of like their main product. Bitbucket's another popular one. I believe that's free for if you wanted to set that up locally, but an enterprise account I can almost guarantee costs money because it's going to want to come with support. And then we have clone. So that clone feature is just a command where you're essentially saying, hey, I want that repository and I want to download it to my local workstation. Then you have the add or remove commands, which is how you add and remove items from your staging area, and your lab's going to cover all these different commands. And then you've got branching, which is where you're making a full copy of the parent branch. So when you clone a repository, you've got the core repository on the master branch. Then you could create a working branch, make some changes to that, test them out. Let's say they work. All right, then you can create another working branch off of that. And just each one creates a full copy of the code and allows you to work with it without affecting the main code, and it makes it easy to revert and see what changes it is that you made. It gives you the ability to resolve different conflicts if two people are, like committing this at the same time, or maybe they have different ideas. And you can also see differences in the code by comparing the commit hash. So the commit hash you're going to find in the lab comes from the output of the git log command, where it's going to show every commit that was made. And what a commit is, it's saying like, I'm done working, I've tested these are good to go. And you always want to make a nice little comment with those commits, letting them know what changes you made to the code and why. Code reviews. So in an enterprise environment, or at least a decently developed IT organization or a mature IT organization, they're going to have some sort of change management process. And the change management process that's like saying, I want to add a static route for something. Either it fixes something or it's net new, but I need to make a change to the infrastructure. Well, that change needs to go through a very stringent process where people review the change that you're going to be making, make sure that the change is correct, that it's not going to have an adverse effect. They have to approve that change, and then your manager or architect also typically has to approve those changes, and then you can actually go in and make the change to the system. Writing software is no different. Different type of change reviews, just like there's different types of code reviews. It all depends on where you're working and what their policies are. The benefits of code reviews are they help create higher quality software. They enable teams to be cohesive and deliver their projects on time, and they help identify more defects and inefficiencies to the code, making the software more reliable before it's even rolled out. The different versions that we have are going to be formal, change-based, over-the-shoulder, and email pass-around. Most of them are pretty self-explanatory. Formal is going to be a series of meetings to review the entire code base. So like my change control meetings at Publix, they were definitely more formal. We had one once a week where the entire team sat down and you went over all the changes that you wanted to do for the week that was coming up, because those changes still needed to go up to higher authorities to get approved. So that'd be a nice series of meetings to review the entire code base with a lot of people. And then you've got change base, which is reviews code that was changed due to a bug or defect. So that might not be that you're rolling out a completely new functionality, but that you're correcting something that someone reported either in the beta or as a code bug. At smaller organizations, or depending on what the change is, you could also have over the shoulder, and that is exactly as how it sounds. It's just someone coming by, taking a look at it, and pointing out anything that they see right then and there. But the benefit to that is it is quick, and it provides a direct interaction between the reviewer and the author, because they're sitting right behind each other. And then you've got email-based pass-around. Now, this could actually be automated for any time if you had an internal code repository. Anytime someone made a commit, they could then use things like webhooks to send out an automated email to anybody that needs to review that code, and then it's passed around to all the individuals. So some of the benefits of that is obviously the automation aspect of it. From like a control system, and then your other developers can review the code, so it makes it for a pretty efficient portion. All right, so for the most part, that wraps up what we're going to be covering for Module 1, and want to do just a quick little brief summary on everything we've covered. We've covered myself, my experience with Python, Devnet, and the Devnet certification program. Before I get off on that, while I have it in my head, I do want to let everyone know that Cisco actually has a free learning platform called Cisco Devnet that's available. There should be a link to that either in a announcement or in the module. You can go create a free account, and they've got tons of different modules, lectures that you can walk through, video courses, tutorials on APIs, and a lot of the tools that are also going to be covered in here. So I always recommend to people, if you're struggling learning something, it may not be that the material itself. Some material I've had to read several times before I actually even started to understand the basics of it. But something that can help is not, going over the same material, but gathering information from multiple sources. So I do recommend that you check out Cisco Devnet. I've finished quite a few courses in there myself. Just a great resource. Cisco did a really good job with it, and they even have online sandboxes that we will be using in our lab so that you can practice API calls against real Cisco software-defined networking solutions. We gone over your expectations and breakdown. Biggest things I can say is I'm very strict on my due date. So when something is due, that assignment is locked. Make sure you complete it and make sure you take it seriously. If you turn your lab in and it's only half done, you're only going to get credit for what was actually completed. And you're only going to get credit for some things that were completed right. If you're shooting me screenshots of some things that never worked, you're not going to get credit for those. Quizzes, those come from a mixture of the book, the lecture, and the labs. Also, I may assign some additional required reading. And I want to point out, I don't necessarily expect you to read these things cover to cover, but it is important when you're given assigned reading that you at least flip through it and know where material is located, because I think that's just as important as anything. But also, walk through your labs, actually get a good fundamental understanding, because a lot of the questions from the quizzes are going to be theory-based in that I'm assuming you understood what you completed in your labs. If you have any trouble, please reach out to me via text message. We've covered the basis of software-defined networking, what it is, and how it differs from traditional networking, how we're moving to more of a rack-mounted server model, and a lot of the configuration changes are done through a GUI or through the API for the SDN application, and then those changes are pushed down to the network devices. We've covered APIs, what they are, and trust me, you should have a much better understanding of what they are, how we're going to interact with them, and their use cases in today's IT infrastructure world. I really recommend that you become familiar with at least the theory on APIs, because they have blown up in popularity. Everybody wants their if I'm going to go purchase something, that's one of the first questions I have. Do you have an exposed API? Yes or no? If it's a no, that's just such a big turnoff for a lot of companies right now, with as popular as they've been coming, and with everyone exposing APIs so that we can script against them and tie it into different vendor systems. We've covered scripting and coding, that this class is going to be focused in Python, and the SDN VM is available to you. Again, have faith. I'm not asking you to do a lot of math. Yes, coding is extremely strict on its syntax rules. What can help you with that is using a code editor such as Sublime Text, Atom, or Notepad++. The code editor just needs to know what kind of code they're looking at. So if it ends in a .py, it's going to recognize that that's a Python file. If it's a brand new code that you're entering, just look it up on the internet, but there's ways that you can actually define saying, hey, just to let you know, this is brand new code, but this is going to be written in Python, and you'll see the benefit right away, but because it really helps with a lot of those grammar control areas, considering software development is so strict with grammar. Cover the different net DevOps tools, things like curl, Linux, Postman, all of which we're going to be covering, Docker containers, the SDN VM, and we've covered Linux and how important it is that you understand Linux. You keep working, you keep practicing with Linux. If virtual machines just aren't your thing, that's kind of like how I forced myself to do it, was trying to use a Linux virtual machine as my daily driver. That helped out a lot, but also Microsoft finally got on board, because I think they were receiving so much pressure. There is a Linux subsystem for Windows feature that you can turn on in Windows 10, where you can run Linux on top of Windows as though it was an application of some sort. So I've got that turned on. I love it. It's great. I was so happy Microsoft finally went down that road. It's free to set up, and a simple Google search will show you how to install that. You just need to enter a few PowerShell commands, and then you can go to the Microsoft Store, choose your Linux flavor of choice. Beginners typically go with Ubuntu or Linux Mint. I would highly recommend Ubuntu, which is a Debian base. But if you've already got familiar with, maybe like SUSE or a different flavor of Linux, you can use that as well. And then we've gone over the software development lifecycle, the different stages and how they're used to better develop code, and how they've kind of taken the software development lifecycle to develop these software development models and methods, which help to turn out more efficient code and promote collaborations amongst different developers. We've gone over the Git application, which is going to be covered in Lab 2. So after your initial lab, which is just a Linux refresher, you're going to have your Git lab. On your labs, please turn in the answer sheet. If you turn your labs in and anything other than the answer sheet, it just raises a red flag. It's suspicious. And I'm just not going to accept it, plain and simple, because I've had people try and pull fast ones, and if you haven't had me in the past, you'll just know, I'm just telling you right now, best case scenario, if you want to know if something's okay, just shoot me a text message. If you try and kind of turn something in half done and say like, oh, I didn't get it finished because XYZ, that it's just plain and simply, it's not an excuse. The only excuses are going to be emergency situations, in which case you will have documentation such as a hospital visit or something. They're going to give you some sort of documentation, and I'll just ask for verification that you actually had an emergency come up. But other than that, my due dates are final. And you can work ahead. As I develop the material, I will have it posted. You just can't unlock the next modules until you've completed everything from the previous modules. So that includes completing the quiz, turning in the assignment, and watching the lecture. Code reviews. We've gone over code reviews, how they're similar to change management reviews and how they're helpful. Developing software is a very collaborative thing, as so is IT. IT is just not that environment, that stereotypical job that it's had in the past, where it's one person who is not very social. IT is now a very collaborative environment. You've got to really start working on those soft skills, and code reviews are going to help you to become a better developer, learn from more senior developers themselves, and also identify bugs and defects. And we've learned about the different types: formal, change-based, over-the-shoulder, and email pass-around. No demo necessary really for this lecture. I'd rather, Linux, you've already had the course. You've got the assignment ready to go. The lab's ready for you, so you can go ahead and get started on that. With Git, I just recommend, that is a Linux application, so I've given you examples in the lab sheet itself with screenshots and explanations. Again, please do not spot read. If you spot read, chances are you're going to miss something. So with Git, I would also encourage you to try and learn Linux built-in help functions such as the man page or the help option, to learn what your options are and how to use them. The Git book is actually free to download from the site, and I don't think I have it posted right now in the course module, so I will get that posted for everyone, so you can even go ahead and get yourself a free copy of the Git book in Kindle format, PDF, however it is that you want, but the electronic version of the Git book is available and it's free. If there's any questions, I will have a discussion board for each module and each lecture, so that you can just ask, general questions about the lecture. That's going to be separate from your actual graded discussion board, so that's optional. But I do encourage you to utilize those discussion boards, because chances are, and those chances are extremely high, that if you have that question, someone else has that question too. I also like to encourage people to kind of get over your anxieties or nervousness about quote unquote looking dumb or inexperienced. A lot of students have been expressing that to me lately, and I would just say, no one was born with this knowledge, and if anybody's going to be rude to you about the fact that you don't know something, they're just not the type of person you're going to want to learn from anyway. So ask away. There's no such thing as a dumb question. I do believe that. So use the discussion board. I also have another ask the professor. If you're unclear of something, please reach out to me. With me, you're definitely going to be better off with asking me and confirming, rather than assuming and potentially taking a grade hit on any graded item, that is. So I hope everyone enjoyed the lecture. This is easily going to be one of the most advanced courses you have at FSCJ, not in terms of it's hard, but it's really cutting edge technology. I mean, the Cisco Devnet certified book, it was not available for my last software-defined networking class. It just came out, and it's just really awesome that we've kind of been on top of this material before it has even become a norm in the industry. So we're already on top of it. We're already trying to teach it to you, and it's blown up in popularity, so I'm glad we've remained on top of it. So if you have a question for me, again, you can reach me text message, discussion board, email, Canvas. Text message is always the quickest way. And I look forward to this semester. I really hope everyone enjoys it, and have a great rest of your week. Thank you very much.